going to have today is different. It's not technical. I always tend to give something else, a different thought, a different mind, a different kind of, at least my vision on how the future is going to be. That's why I had the title, Cloud Native, whether it's an evolution or a revolution. If I'm going to ask you, who do you think that the current way we do development and all the new technologies is more like a revolution compared to what we did the last, let's say, 5 or 10 years? Is it something really new? Or is it different? Or is it an evolution? Okay, good. And the rest of the people, the other 70% are still sleeping, or? No. I want to take you along on my vision, so I'm going to present it more like a story. And like any good story that happens... Oh, where is... Oh. This is going to work better. All good stories, like in the past, start with back in the days, or once upon a time in the past. If I'm looking at the people here, probably most of them are way younger than I am. When I started in IT, it was always, when we had a server, when we wanted to add a server, it was really, really a server. So we had to a physical shop, had to buy a physical server, took it under our arms to the shop, from the shop to our office, and there we had to install a web server or a mail server. So if you were scaling the stuff like we do nowadays in the cloud by default, we still had to go either first to our manager, ask for a budget, ask for money, then we could go to the shop, wait a few weeks before all the different parts got delivered to the shop. We put them together because we like to look all the technical details and all the specs, so we always build our own servers. Was it on purpose? Was it not that we didn't have virtualization as we had nowadays? We did, but only for the big servers. Who do you know the mainframes of IBM, for example? Anyone work with them? Well, that's more people than think that we're doing some revolutionary stuff nowadays. The mainframes in IBM had virtualization built into their core for many, many years, even before we started doing servers and that stuff. Why did we do it like this? It was not that we couldn't install a web server and a mail server on one machine. We could, but we had slow internet connections, slow hardware, and we didn't want that if my boss would send out a PowerPoint of 10 megs, that we couldn't send out mails anymore. So it was a kind of isolation of resources, so we could guarantee the performance, but also the security and the maintenance. I mean, we had a department where someone who did the mail environment, Domino, because I have an IBM background, so that was a different guy than someone who did the web server. So if they would work on the same machine and something changed or something failed, we would all point to each other. So that's why we, besides the hardware and isolation, we always decided to buy different kind of servers. When virtualization came along on the commodity hardware, the ESX or the XN or, I don't know what you're working with, but that was all when the hardware got faster, we got bigger servers, multi-core, multi-CPU kind of servers. So the hardware specs got faster and we could run more servers on one machine, but we still had the same problems. In the past, when I had my server, I had to take it to the department and they installed like Linux on it, or Windows, or OS2, or one of the older agent systems. Oh, that was a blinch. That was still when we did virtualization, because then I could create my server way faster. I had my base image, but someone need to install the operating system. And we still had the same problem about the maintenance. So why we did it is, that was what happened. But if we had the virtualization going on, we still had more or less the same stacks. It's just the hardware layer which was different to it. And we still had the same separation. That's why the DevOps thing came along later on. We still had operators, installing operating system, middleware, and all that kind of stuff. Later on, containerization. I guess you all know that kind of stuff. What was really different compared to the virtualization before is that we did not just install the middleware operating system and someone from the development delivered the application. No, the guys from development also delivered the application binaries. So the way we packaged our application and the things we had to install, that's what really was the main differentiator between virtualization and containerization. And that also made it possible for our developers to, for example, start our environment, do testing all over again, and instead of waiting 3 months for another test server, or once they screwed up their acceptance environment, had to wait 3 months, they could start all over in a matter of seconds instead of months. So that's what's really speeding up our development. Was it really different? When I read Google and all the other Medium blogs, it was really a differentiator. But if we're going back, the number is here, we not only had virtualization in the IBM systems, but containerization is a technique already introduced in 1983. Anyone know who was the inventor or the... None? It was the Sun. Sun had already containerization built in their operating system in 83. So it is not nothing new. It's just that it got adapted by the public. And so at the end of the day, we're trying to solve the same problem we had in the past. This is a bit blank. And one of the things I would like to compare, and I will do every step we make into the future, or getting near to the future, I would like to compare it to what Henry Ford asked when he started building his first car. If we had asked people what they wanted, they would have said faster horses. And that's what we see along when we're going from hardware to virtualization and to containerization. Nothing really changed. It's just the way we package. It's just small differences compared to what we're used to. Is cloud native really different? I don't think so. I mean, we introduced what we call nowadays serverless. But at the end of the day, it's just who is maintaining the system. I have a developer background, so if I am a developer, nowadays I go to AWS or I go to Google or any other provider instead of going to my own IT department. And the main difference is that if I go to AWS, I can put in my credit card and get my environment faster. But the way I work, or the way it is arranged underneath, is not really different. We get more flexibility, but the flexibility is because the environments spin up and I can throw them away anytime I want to. So, again, not really a revolution. So, the few people who were sleeping, or the cunts who put up their hand for the evolution question, I tend to agree with them. And if you are going back, like the virtualization, if we compare it to what we did at Java and the Java application servers, we already had something where we had EAR files. EAR file was a complete application. We could deploy at any Java application server, and the application would run. It's comparable to what we do now with the functions as a service or the real service environment. So the concept is still the same. Nowadays we do it for many different programming languages. Back in the days it was just Java, but it's still the same as we did for the last, let's say, 20 years. And if we look at development, so this was more or less like the infra part. If we look at the development kind of stuff, again, 1983, which seemed to be like an important year. I think some people here in the room might be born in that year as well. But Borland with Pascal. Anyone programmed with Pascal? Anyone work with Borland, the old original text editor? IDE? 1, 2, 3. When I was back in school, that's how I learned programming, with the green and blue and the the green and blue letters in the background where they did a complete study. It was nice, but the concept nowadays is still the same. If I start up my Eclipse environment, I still have a text editor. There's still some compilation, word completion, all that kind of stuff. The concept of how we develop what we do, and at least how we write our code, let me put it like that, didn't change during the last over 30 years. So what we do as a developer, we write the code, compile Java. So indeed, I need to compile my code. Nowadays, many more or less scripting like nodes and that kind of stuff don't require a compile stage unless you do generation of code. We run it and we test our. Nothing really changed. The only thing which has changed over the last year is we introduced more languages. I think over 250 different languages nowadays. And every language has a different purpose, a different kind of thing they're good at, all that kind of stuff. But I think a new language every month, Go, R, I tend to still do Java, but only new languages. And another thing which has changed, when I started programming, there was really a Java library for handling HTTP requests. Nowadays, I just write one line of code, and the HTTP request which comes in is automatically translated to objects, and from objects I just write it back. And everything is handled underneath. So we have more functionality in the sense of libraries or application servers available. Things we had to write manually in the past is now generally available. It can be compared to services or libraries. So what does it give? Does it really change? Do we, as a programmer, need to write less code? No. If you look at the number of lines of code, it's the same. It's just within the same line of code, we generate way more functionality. So if we would have the same tooling we have nowadays back in, let's say, 20 years ago, we could have written the complete programs or the internet banking application in a day's time. We still have a fully job available for writing code. Why? Because new functionality is there, base functionality is there, the requirements change. People want more and more and more functionality available, and more automated, and more generated. So it's just the granularity of the services, the granularity of the building blocks has changed, and also the requirements. So nothing really there. Is it different? Again, I think the way we develop now with the services and the libraries available in combination with serverless is the fastest horse around today, but not really different. So again, I tend to believe we're just doing evolution. As anyone know here, and there was a talk about it yesterday as well, if you wanted to do fully cloud native or fully serverless or want to make use of all the functionality available now, we need to change our architecture of our application. Decoupling. So nowadays, when I build microservices, I can have a dedicated department concerning about our billing engine. Other people I can, or if I compare it to an interbanking application, I can have a different team for the mortgages, for the payments. They can work in parallel, where I used to have one big monolith application. I now can split it up over different themes. But I need to adapt the architecture of my application as well in order to achieve those kind of things. But is that new? Not in 1983. But the original specification for services, and although this is SOAP over HTTP, which is slightly different than we nowadays do JSON, but still we do the envelope and that kind of stuff. This is already in 1989, where we all did SOAP requests over HTTP, which had the promise, we all do microservices, we build services all over, we're just going to split up our application, but somehow that got lost in the translation as well. I do believe that architecture is key in order to reach the next level, and besides the SOAP service, we also had EGBs and that kind of stuff, but nothing really changed. Again, like going from virtualization to containers, which was more like packaging. If you want to apply the good architect rules to our application, again, it's like packaging. How do we package our application, the granularity of our service, the way we deploy it? That's the key and the main difference. That's where we get agility for delivering a new functionality way faster. Again, Different? No. As you've seen, all the techniques we use nowadays are available different. I agree, they have evolved in little details, but they are available for many, 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 many years. So why is there no real revolution? What we people are afraid of changes. People like to have a safe harbor. And if there is something really new pops up, we tend to ignore it or are afraid of it, or at least, unless there is a majority of people who is accepting the change, we refuse it, we reject it. We are afraid of the unknown. And although we are all technical people here and want to learn something new, the things we're going to learn here are different, are new, but only on a marginal scale if we look at the complete picture. Yeah? It's in our genes. There's a good book, Homo sapiens. Don't know if anyone knows it. There are a few good books about how we people tend to be afraid of new things and how we are going to act on that. We are afraid of the new things. A few examples. When we first started writing, there are some Greek letters about it. They were telling us and the people that if you're going to write down everything, you're going to be stupid. Why? Because if you're going to write down everything, there's no need to memorize stuff. And if you don't memorize stuff, you're going to be stupid. So the art of writing would make people stupid. That's what, if you look at that point nowadays, then it's completely different. But that's how people thought back in the Greek ages. Again, newspapers. Also, people were talking to each other and gossiping. And you would meet other people in order to tell them what your neighbor did or what happened in the village next to each other. With the introduction of newspaper, where someone could go to a shop and then buy a newspaper and sit at his table and reading the newspaper, there's no need for interaction anymore. So with the introduction of newspaper, people would get lonely. That was the sense that day, in those days. And even not that long ago, there's a famous article written by Nicholas Carr, Is Google Making Us Stupid? Why? Again, more or less the same reasoning. If there is some kind of source which has all the knowledge in it, and we could query that source, why do we need to memorize stuff? Why do we need to learn stuff? If Google is there, it will make us stupid because we don't need to memorize stuff. The pictures are a bit vague, but this is, I think, a good example, and I'm not sure where you people notice it, but when the first Tesla cars came out, they had a grill on the nose. And you know where the grill in a car is for? I have a petrol engine, and the petrol engine needs cooling. A Tesla has an electric engine, so it doesn't need the cooling like a traditional petrol engine. But I did a test. If they would remove the nose with the grill, we as men tend to think big grill, that means a big engine, so a muscle car. Without a grill on the nose, it would more seem like a dummy car. So the first Tesla cars had a grill in front of it. And every new generation of car they introduce, the nose became smaller, the grill became smaller and smaller and smaller. Why? Because we got used to it. And the latest model, the Model 3, no grill at all. And if I look at it, I think it's still a bit of a strange car, because it has no grill and you're used to it. But that's how we people tend to look at new developments. But what if we look at a bigger picture? I'm going to make a step to a different road. What if we look at how things are changing for now? How things are evolving nowadays? Then we see that the world is democratizing, which means traditionally we had big energy factories. In the Netherlands, I'm from the Netherlands, we had like 6, 7 big plants and they produce all the energy for our complete country. And they had power. If you look at America, one of the main reasons Donald Trump or those kind of people, because they supported the energy system. But there is another thing going on. With solar panels, for example, anyone can become and produce energy. And we have complete villages, or part of villages in the Netherlands, which bought solar panels together, like a cooperation, put them on the roof, and as a cooperation, they start buying and selling energy back into the system. And there are easy math calculations that there are more than enough roofs in the Netherlands available, so everyone could become its own producer of energy, and then we don't need to have those big, powerful energy plants anymore. Is solar panels the only one? No. If you look at different companies, WeChat, for example, how it's going to change telephony. Airbnb, I'm not sure who stayed in a hotel here, but Airbnb is changing it in the same way as we do for solar panels. Slowly, we are changing the way companies are built nowadays. No more big, central, either by the government or other reasons, centrally organized. We are all familiar with those kind of evolutions, let me put it like that. Although that's more like a revolution to me, because we always thought about kings and central governments and that kind of stuff. But still, a small evolution. But if we look more into detail of what's going on, then we see that it's not just there for business. If you look at glasses, for example, many people here have glasses on. With glasses, we have the capability that everyone is seeing the same thing. If we go back in the, let's say, 2 or 3 centuries when there were no glasses, if you couldn't see, then you probably ended up somewhere in the sewer or got expelled or whatever. You weren't part of the community. Now with glasses, I think that's the best example, everyone can see the same, so they're part of the community again. But a real game changer, and you probably have all heard of that, is artificial intelligence. Not the kind of playing with big data as we know it, but in 10 years' time, there will be a chip available, which you could put into your brain somewhere. Not sure where you want to put it in your brain, but somewhere in your brain, and it will be available, and this is really a prediction made by the right people, let me put it like that. You can buy for $100 a small chip which you put into your brain and which give you an IQ of 100. So everyone, you can go to a shop, and if you're not smart enough or your child is not smart enough, you can go to a shop and buy a little chip, like you buy glasses nowadays, and your kid is smart. That's going to change the world, I think. And it's not on a social and emotional level, that will come later on, but the things we do nowadays and the traditional jobs which got paid the most, like lawyers and pilots and doctors, those are all jobs which require a lot of intelligence and the capabilities to memorize a lot of stuff. With these kind of techniques, everyone can do it. So the way in 10 years' time, or 20 years, give it a break, jobs will differ. People will learn different stuff. The impact, everyone becomes smart, or at least equally. And the way our current school and educational system works, that has to change. We're now investing a lot of money in giving iPads to schools. But in a few years' time, the iPad is something completely different. So why do we invest that kind of money and time into the current educational system? So most people know this picture. We all have a left brain, and we all have a right brain. And we tend to think that one half is responsible for all the emotional and creativity, and the other stuff is about the reasonal and the thinking and the learning capabilities. But in truth, we always use both sides together. So if you try to solve a problem, both parts of your brains are working together. And the thing with our people is that the brains require the most energy of our system, of our body. So most of the energy we consume goes directly to the brain. That's why we all have kind of theories that once we started cooking dinner or that kind of stuff, that's when we made a huge dip in our IQ and we're capable of evolving way faster than all the other people. So, but in order to reduce the amount of energy needed, our brain is optimizing a lot of stuff. If we look at stuff, we already come up with a conclusion. We think that this will be the solution, so we're already reasoning in our own mind to that specific solution. Don't know, you're already familiar with that. And I think I have a nice...
To test just how much attention the attention-stealing design of the new Skoda Fabia actually steals, we left one parked on this ordinary road in West London. We wanted to see if its sharp crystalline shapes, bold lines, and lower, wider profile would attract the desired level of attention. Will the 17-inch black alloy wheels stop passers-by in their tracks? Will the angular headlights attract the attention of other road users? Will a crowd gather to check out its fresh, sporty look? Well, not quite. But did the attention-stealing design distract you from noticing that the entire street has been changing right before your very eyes?
Who already knows this small movie? For the people who don't know this one. What has changed? The bikes? More? The background? Did you, for example, see there's a woman suddenly here? And there was a huge collection of birds flying over. Let me finish this one.
Don't believe us? Have another look. Did you spot the van changing to a taxi? How about the scooter changing to a pair of bicycles? Or the lady holding a pig? Let alone the fact that the entire street is now completely different. Didn't think so. So there we have it. Proof that the new Skoda Fabia is truly attention-stealing.
Not sure whether I would draw the same conclusion, but... Who did see all the changes? Probably none. That's how our brain works. I mean, this is just one of the many examples. There are examples of ballerinas flipping around, and just to make us aware that we have a very, very, very limited brain. We already think about the solution based on what we know. That's probably one of the main reasons why there are no real revolutions going on. And everything we do nowadays is actually the same, based on development, applications, the things we did for the last 20 years. But that's why I think that those little chips, which will be available in 10-year time, they are going to change the world. Because they are not optimized for the same thing we did for centuries. So if I have my left brain side replaced by a small chip, that's not influenced by all those kind of steps. It's translating direct signals. And if it has a bug, so for example I didn't see the taxi, the cab changing into a van or whatever, then a programmer will look at it and will change it to something that it will recognize those kind of stuff. So this is dramatically going to change the way we're going to work and think and live in the near future. And the same conclusion is this only based for IQ. We also have emotional and social capabilities. We tend to believe that's the right side of our brain. That's why I'm telling you the right side of our brain is probably going to be more important than the left side. Because as we can foresee now, and that might change in the near future, there will be no right side kind of chip available with all the creativity we think we people have. So creativity will be the key in the future. Think about what we do as technicians. Is it real? Yeah. BCI is already possible. Brain-computer interaction. And it is really available. It's really possible. There are small chips available we let blind people see. Not in detail, not in color, but just they can recognize images and shapes and small colors and that kind of stuff. That's already available. There are people who were born blind but still, after 40 years, went to the surgery, came back a few days later home and could suddenly see. Not sure whether the marriage would keep up, but that's life nowadays. And we can move muscles, mind-controlled. There are systems available where I put some sensors on my head and I look at a text. And the letters I read with my eyes can be translated. It's a bit double. So I put in a screen and then I get the same letters back if it's going okay. But these are already the capabilities. And we don't always need a chip in the brain. We've all seen those weird signs where you put all the sensors on your head. But they're looking to other techniques as well. They, for example, look at the oxygen level in your blood, because the oxygen level in your blood depicts what's going on in certain parts of your brain, for example. And this, for example, is something you can buy on Amazon nowadays. It's a small plaster, something you put on the top of your head, and it's directly interacting with your frontal cortex. And there are two modes within the system. One mode makes sure you feel more energized, and another switch you put on, and you can concentrate on the things you're doing way better than you used to do before you put on the plaster. It's something you can buy on Amazon nowadays. So it's not really the future. And there are a lot of open source tools available as well. What you see on this screen is a kit, like everyone had an Android of an Arduino board or that kind of stuff, where they were playing around. This is more or less the same board with the same plug and play kind of stuff. You can buy it. And there are drivers available, so you can read it. So you can put this on your own head and see what's going on in your own head and look at it at the screen. There are still many problems. It's not perfect already. One of the biggest problems, for example, is that we tend to think in tasks instead of things we do. So instead of thinking, I'm going to need to move my right muscle and then open my hand, no, I'm going to grab the book. So we need to make a lot of translations. And most of the systems we know nowadays are used for reading stuff. And what I meant is that we read what's going on in our mind. It's always the first step. And there, of course, there are a lot of ethical issues. Suppose that we know what everyone is thinking for now. And I could read your mind and open your mind and then go through all the things which happened in the past, what happened in your youth, but also what you were thinking yesterday, or when you're walking across the street, when you're walking by a shop. So the shop could read your mind and see whether or not you're interested in that certain dress or shoes or that kind of stuff. How do we deal with those kind of situations? But also, if we're going to write back into the system, we can decide what someone's going to hear, see, read, smell, taste. What is left of our body, of our own soul in those kind of situations. So a lot of ethical issues. Impact on the short term, I still tend to believe that, for example, the keyboards as we know it are going to disappear on a short term. Why? You can already read letters. So why do we need those legacy systems which are really slow? Mind control about what we see. If you're going to, there is, for example, a So glasses available where we look at dashboards, and with dashboards we can zoom in and zoom out and then try to solve problems way more faster. So there are a lot of things which makes our life easier on a short term. And I think the most, after we have the chips, the most logical next step will be that we can read our thoughts, because we already influence how they're reasoning. So before we can make sure that they draw into a certain conclusion, we need to know how they think and have ideas. But if you can copy those ideas and thoughts to another system, I would be glad. I have at least 2 times a week a really boring requirements meeting for a new project with one of our customers. So if I could plug in my laptop into his brain and copy all his ideas and thoughts into my laptop, that would make my project way more efficient. Just one of the things which will happen in the future. Then if we have those capabilities and we already have a chip which can copy the thought, translate via reasoning, translate it into a solution, do we need programmers? Yeah, but they will do different things. They will think different and they will solve different problems. And what if we could connect all the brains together? There was a big hype, blockchain. Blockchain was something that would decommoditize all the, let's say, transactions within a bank or knowledge. There was no real owner of your money, or with the cryptocurrencies, for example. What if we made the equal system when we connect all the brains together? Then we all know some part of the solution, or I need to stand close to you and then we can solve the issue together, but if I'm standing next to someone else, I get a different part of the solution. Is this a revolution? I think so. That's why I mentioned here that we no longer need horses to build horses. It will be completely different. How will it look like? To be honest, I have no clue. Why? Even my brains are too limited in order to come up with the ideas and thoughts and the possibilities and the capabilities. But it will happen. Will it happen soon? Yeah. I think most of us, in our age, if we look back into a certain point in time, in 20 years' time, we will see that our brains are far too limited. And way of the things which were automated by then, do we need to do manual nowadays. And if something I'm going to do different with my children is let them be creative. I'm not sure how the future will look like, but I tend to invest more in their creativity, pictures, writing, photography, all those kind of creative stuff, because I know for sure that in the near future, as we foresee it for now, there won't be a replacement for that part. That was my view on the future and how it will look on a short term. Do you have any questions?
Thanks for this great talk, but I'd like to understand what, in your opinion, is the difference between evolution and revolution? Is it about timing, about the dynamics, about the impact, about the collateral damage?
Good question. I think evolution, in my mind, is going along on the same path, and there are small differences. Like more or less like Darwin was looking at species. We are evolving, and there are small differences, but there's not really a huge bang which makes a huge difference. And revolution, from my point of view, is something which is really going to dramatically change the way we either work or think or handle stuff in a really short time frame. If you compare it indeed in that time frame, what we now define as a revolution could happen on an evolutionary base, but would take, let's say, 1,000 years, while on a revolutionary scale, it would just take a few months. That's more or less, in my opinion, the main differentiator. That's why I think that what we do now is evolutionary, we gradually move and improve, make things better, make things more easy for us. So if I'm going to pop up at work tomorrow, I don't need to open VI and that stuff. My life is way more easy than it was 10 years ago. But nothing really different has happened. And if we have the, let's call it chips in my brain, then all the stuff I'm doing nowadays, coding, writing stuff down, that's not how I'm going to work in 10 years' time. It's completely changed. That's, for me, is the difference between revolution and evolution.
Well, if we look from the perspective of the universe, then...
It's still small.
Yes.
Yeah, I agree. I agree. And again, like I said in one of the last slides, I have no clue how it's going to be. My brains are too limited as well. So it's indeed from my own perspective. And everyone might have a different definition of revolution, true. Yes. But indeed, on the 13 or 14 billion of the, it's still relatively small.